Okay, good. So we have quite a lot of people joined already, so welcome everybody to our first webinar on sports. We have a VIP speaker, Daniel Pisarski, who is our head of sports in the product team in the US. It's 4 a.m. in the morning there, so we woke up early for us. So just appreciate his effort. And we wanted to do a session talking about remote production. So Daniel will share some use cases and some examples and talk about some features. And please feel free to ask questions and also to share some of your experience. The goal for us is to encourage you and the customers to find more opportunities using LiveU for remote production. So we want to learn the best practices from different parts of the world. So Daniel, I'm giving you the stage and you can start your presentation.
Thank you very much. Good morning or afternoon or evening to everybody. Very happy to be here and doing this. So I've been in this role of product manager for the sports team for I guess about 6 months now, and working with the team in the US as well as with Ophir and y'all, and gathered up these use cases largely with the team in the US because we wanted to identify a couple of the places where at-home production had succeeded with that team and how those customers had overcome some of the specific problems that I think a lot of customers looking to do at-home production run into. And I think in a lot of cases what you'll see is that there are some homegrown remedies that they've used to overcome some of the problems or some of the challenges of at-home productions. And hopefully in all of the cases, there's also either a very recently launched LiveU feature that really helps with that issue, or a very soon to be launched LiveU feature that helps overcome that issue as well. So the homegrown remedies are great to know and can get, keep a customer moving today. And then, the deeper integration with LiveU will make that even easier to solve either immediately or in the very near future. And then certainly let me know if you have any questions as we go along with it. I had also hoped that one of the pre-sales engineers from the US was going to join me. I certainly can't say that I'm the deepest production expert in the world. I didn't necessarily come from a background in production. Definitely come from a background in video technology, but not necessarily in sports production. And some of them had a little bit more experience there. So maybe they'll be able to join as time goes on. I know it's, early hours here in the US. So today we're going to, just a quick agenda, take a quick look at what at-home production is. I'm sure most people on this call probably have a pretty good grasp of it, but we'll just cover the basics, make sure we're all on the same page, and then we'll look at 3 use cases that are customers here in the US who are successfully using at-home production with LiveU gear, in some cases almost every single day, like in the case of L2 Productions. And then we'll take from those use cases the common problems and talk again about the solutions. We'll talk a little bit about the solutions when we look at each use case as well that they use to overcome those problems. So the 3 customers we're going to dive into, one is the New England Sports Network. They produce professional baseball games. The other is PGA. They produce professional golf tournaments. And then the last is a company, a production house called L2 Productions. And they produce what we internally, and I guess in the industry as well, really refer to as tier 2 and tier 3 productions, which can include some professional, but not like the top 5 sports in the US, but then can also include some non-professional things like the collegiate market or even the high school market sports productions. So we'll start with a little bit of talk about at-home production. This is obviously, again, I think probably a lot of people here are very familiar with it, the model where you keep the sort of very expensive part of the production, which is usually the big production van, sometimes even the big production, tractor trailer or 18-wheeler home, and don't have to roll that to every individual site in the more traditional model where you brought the production van to the venue or the stadium, you had all the cameras in the venue or stadium and they wired directly to that production van sitting in the parking lot. You did your switching and production right there in the van and then did your transmission there from the van as well, usually via some sort of pretty high-priced transmission step like satellite or fiber. So this is the model that's obviously been used for years and years. It certainly can be a reliable model. Its real downside here is it's an expensive model, right? That production van or truck is expensive itself. Moving it to another location is expensive. The amount of staff that you have to bring is usually one of the highest ticket items in terms of what you're paying for on the production. And the idea that you can centralize all of that, either literally for a lot of the production houses that started doing at-home production, still do it in the existing van, but just literally leave the van in one location and now have all of your equipment remote and brought back over some sort of remote backhaul technology like LiveU. Or in an increasing case, one of the trends we see here in the US is in a control room that was built specifically to be a at-home production studio, because you build it in a location or in a building that has a lot of connectivity and a centralized location, and now you can just do the production right there. Not only does this let you leave a good portion of the staff home as well as the expensive truck, it also lets you do kind of an economy of scale in that you can rapidly do a production in, at least I'll use the example of here in the continental US, do a production in one part of the country, for example, for a couple hours in the afternoon, and then immediately do another production in another part of the country because you've deployed a second camera crew and a second set of LiveUs, but all of your core technical director, switch operator, everybody that is working in the production room stays home and is still available for the very next game, even though that might be a very different location in terms of where in the country they are. So that's obviously a very great model for us because you need some sort of technology to then backhaul each of these individual cameras at the location and bring them back to that centralized location, and something like cellular bonding as a backhaul technology is a great fit there. Wait, I just see Lewis texting me. Hold on, let me just respond to Lewis here so he can join us. So I think he's going to register now, so if you can keep an eye out for that. So our first example, picture notwithstanding, I should have swapped in an actual picture of the Nesson crew there, is what we call a regional sports network. I don't know if that's always called the same thing in different countries or different parts of the world, but that's an entity that owns the broadcast rights to a specific sport and team in a region and can broadcast those games in that region. Sometimes a different rights holder will own the rights for the national broadcast, and they'll own the rights to broadcast just in a given region. In this case, it's the Northeast, like the New York and Boston area here in the US, and they own the rights to the Boston Red Sox baseball games. So what they were looking to do specifically was reduce their cost on producing the spring training games and preseason games. Obviously, the actual season games are quite big ticket items and have a huge revenue associated with them. And so while it would also be nice to reduce costs there, and over the years of working with LiveU, they've come to trust the at-home production model more and more, their initial thought was these preseason games are quite valuable to us. We can still broadcast to them, but it doesn't generate the exact same revenue that a seasonal game does. And so here we can lower our production cost. We can definitely increase our revenue, obviously, because the revenue is a little bit lower for those games anyway. And because the revenue is a little lower and the total eyeballs on it are a little less, going back to the kind of 3 years ago when they first started with this, they were willing to take a little bit more risk in how they did that. And so a group that was very familiar with the on-site production model was willing to take that step into the at-home production model based on doing it with those preseason games. They actually started out with the LU 500, and here in the US, they were what we consider our first real at-home production model customer. But after, since 3 years ago, they've used us ever since, and they've used us for an increasing number of productions around the games themselves. They, one of the things that the salesperson associated with the account had pointed out to me was at the time they were trying to decide exactly different techniques to do this at-home production. They also tested out using fiber and working with a fiber company here in the US called The Switch. I know they're international as well, so you may have them in other parts of the world. And while that certainly was a model that worked, they just found that that was also still too expensive, and that ultimately what was offered by cellular bonding as the solution here was the best cost saver. So prior to us, they were already doing these productions, but they were sending a full production truck and crew on site. A lot of the, for instance, the practice games take place in Florida, so it's remote from their home base of Boston, and they would have to roll the entire production crew and the full production team down to Florida for 30 days during the preseason. What they moved to in terms of LiveU gear was 1 unit and an extender per camera. Again, that was originally with the 500 doing H.264. When they moved to the 600 doing HEVC, one of the reasons they use an extender per camera is they do want to keep a very high bit rate per camera. In our case, they're targeting around 14 megabits per second. I think many of you might know, here in the US for the news crews, our cellular data is a kind of at the median point of cost compared to the rest of the world. In some cases, it looks quite expensive compared to some of the places around the world. And so sometimes our news crews are targeting a much lower bit rate on HEVC to keep costs down and be able to do more broadcast during the month, given their data plans. In this case, and I think we probably see all around the world with sports productions, they were targeting a much higher bit rate on HEVC to keep the quality up with things like fast-paced, sports production. They're using Sony 1500 series cameras. If you're not familiar with those, they're a pretty portable camera. You can see a picture of them there. So it's not what you would consider a true traditional pedestal production quality camera. It is a tripod-based camera, but that camera does have a full CCU and does allow remote control of things like the camera paint functionality. And that was one of the challenges that they overcome. We'll talk about it, was how to still do the camera alignment and camera paint. They go back to a raw switcher. Graphics, I wasn't able to find out exactly which graphics system they use, but I think it's probably something that's very compatible with that raw switcher. So those parts are very traditional broadcast pieces. Once they come back to that central location, they're then using a much more traditional production workflow. They're not, for instance, using cloud production in addition to using the at-home production model. So going back to, they really started 3 years ago, and admittedly, that was before we had some of the features that we now have when it comes to production. They had solved some things themselves, and then are in the process right now of testing some of our newer features. For example, they're just now testing the new Tally Light feature that we offer to integrate with their own CCUs. But one of the key things was to solve what's called camera paint, the ability to go in each camera and adjust things like the white balance, the iris level, to make sure that as you rapidly switch between the cameras, the image visually looks appealing and looks the same between all the different cameras at the production site. So that when you switch from camera 1 to camera 2, you don't suddenly have a change of shade on the green of the field, for example. They still brought a smaller production van on site with the CCUs on board and sent one camera technician who'd be, pre-game, would use the CCUs right there on site, linked to all the cameras there in the venue, and adjust the camera pane options. They found that sending that one truck and that one crew adds some to the cost, but it was certainly way less than sending the big production van and sending everybody to do the production. So it was acceptable to them to say, yeah, we can send down that one technician. They'll do all the adjustments. Still a huge cost savings compared to sending the full crew all the time. They also looked at our frame synchronization on the 500 with the H.264 encoder, which, speaking very frankly, wasn't as tight as even the HEVC encoder is, which has a much more accurate onboard clock and can result in even tighter frame sync between disparate streams today. And they found that it was acceptable to them, even with a game like baseball that's usually harder when it comes to frame synchronization, because you are using different cameras around the field and cutting in between different viewpoints. And so that's a good example of where frame sync is very important, versus some sports that you're able to do a wider shot and a few less cuts in terms of how you're cutting between the action, and their frame synchronizations, can be a little less important. They did find that it was acceptable, but what they did to sort of tweak it to an even better level than what they were getting was pass the video back at the central location, back in Boston, through an external third party, what's called a frame sync, just an external device that lets you plug Genlock into it, and then do some adjustments to the signal, usually at that device. And in that device, what they were able to do was delay an individual signal of one of the many coming from the camera, still by another, 1 or 2 frames. So if in the test pre-game, once they had everything wired and set up, they found, oh, the center field cam looks like it's 2 frames behind, not 1 frame behind, and technician back here in the control room, I can see that one's a little bit behind when I cut between it, because we take a slight jump back in the action when I cut to it. I'll go into this individual frame sync and delay 1 more frame so that now it's more in sync with the other ones. And I know even in a separate discussion with some of you, you were asking which frame sync do they use. I do have the question out to them. I didn't get an answer before we got to the seminar, but as soon as I find out what company frame sync they use there, I can send that to everybody. Moving on to the PGA. So the PGA is the actual, professional rights holder for all of the pro golf tournaments here in the U.S. And what they chose to do, I don't think they use it with every single golf tournament they do, but there was a series of golf tournaments that they were interested in doing this production with. So, of course, golf is somewhat of a unique model in terms of how the production happens. You don't just have the stadium or venue that you would, might even be already wired for things like SDI or fiber. And you would traditionally have some cameras around at different fixed locations and be able to wire them back to the production truck sitting in the parking lot, for example. Golf takes place on this large course. And if you want to get different camera shots from around the course, that's not, that's good. You're already in a sort of portable camera model there and need some sort of technology to take that camera and make it wireless to come back to a location. So some, more traditional models here, as opposed to the at-home production model, would be to use a more traditional point-to-point wireless setup, RF setup on the tournament, and then, be able to do the cameras, just back to the parking lot. But again, there you've got a higher cost where you've got to roll the whole production crew on site. And you still had some challenges when it came to wireless, because if you're familiar with that point-to-point wireless technology, RF technology and cameras, it's very line of sight dependent, something I think all of us are pretty familiar with when it comes to, some RF technologies. And so if you were, just over a hill, or some parts of the, individual holes would have kind of blind spots that they wouldn't be able to get the camera into, and using something like cellular bonding, where you're not necessarily just attaching to your own antenna that you've got to put back in, some central location. You're attaching to a commercial cell tower that's much higher and doing a different type of signal at different frequencies. You can actually reach a lot of those blind spots and still be able to get the signal out. So there is a further case study on the link that you see there on your screen to kind of dig into this one even deeper when you want. I'll share these slides with everybody. I'll have Asaf help me and share the slides with everybody after the presentation, so you can jump on that link and kind of take a deeper dive if you want to. So some of the things that they solved uniquely, again, going back to camera shading, you can see this is a common need. We'll definitely talk about it in the list of common problems. They did also have the issue with how do we get all the cameras in alignment, especially if our whole production crew is remote. They ended up using a third party called LiveU that specifically is looking to solve that problem. They've got their own remote controlled box, one box that goes with the camera and plugs into the camera's either serial or IP port, depending on how that camera works in terms of its remote control. And then they've got a user interface and a box you put back at the remote location that gives you control over all of the camera shading capability remotely. It also gives you, they have their own tally light feature, and because it's plugging into the camera's serial connection or IP connection, it's using the camera's own tally light functionality so that, for instance, the camera operator sees it in the viewfinder when they're operating the camera. So LiveU is a third party that we see coming up more and more for a solution for some of this. We've had some conversations with them. They're very excited to talk with us because they see the kind of strong fit between their solution and our solution and how they work with at-home production. They will be at NAB this year, assuming there is an NAB this year and it's not canceled, but they will be at NAB this year, and we're going to have a further conversation with them there, and I think good chance for anybody that's interested in finding more about their solution to check them out there. They also needed Intercom, not just IFB, one-way communication to all of the camera operators, but they needed two-way communication with all of the camera operators, especially because, again, in this case, they were very remotely deployed around this large golf course. And so even before we had an Intercom feature, which we now have, they had devised their own using IFB as one of the channels, but using channel 3 out of the 4 audio stack that the encoder was able to do even before we expanded to 8 channels as the return channel. And they had just a small box in that link on the previous slide. There's a wiring diagram for the box that they built that would just sort of multiplex that audio. It would use IFB as the incoming channel, and then channel 3 in the audio stack is the outgoing channel. And in both back at the head end and at the camera operator, just split that one channel out so that you could put on a typical two-way headset and have a two-way conversation with somebody using that setup. So at the time, that was a very unique solution. Now, luckily, we have a two-way intercom feature, and hopefully they'll test it out very soon. I had also wanted to find out the exact camera model they were using here that plugs in with the LiveU. I know they're using Sony cameras as well. I don't know which exact Sony camera it is. I believe it's a slight upgrade from the one we just saw NESN using. So I think it's something above the 1500 series. But again, as soon as I find that information out, PGA didn't get back to us in time before this presentation. I'll further that information on. But it was definitely in the Sony line. When we get to some of the LiveU solutions here and we talk about our forthcoming feature that's going to help with this whole camera shading question, I'll talk a little bit about Sony there too, because one nice thing about the Sony cameras is they do all have, even if the one of the connectors on the camera is serial to plug into that kind of camera remote control CCU functionality, a lot of the Sony cameras also have IP control, and Sony actually has their own IP application surface that allows that sort of remote camera pane control. It acts like a software-based CCU. So Sony, in terms of a camera line, seems to play very well with the kind of direction we're going in for this solution for CCUs. So for the last one, I'll talk about L2 Productions, and this is a little different than the last two we talked about. So the last two we talked about were actual rights holders, and they were doing tier 1 sports. pro golf, pro baseball. L2 Productions, they focus on, again, tier 2, tier 3. So here in the US, they do a lot of women's basketball. So still the kind of pro rights holder level, although, unfortunately here in the US, when we talk about women's basketball, it doesn't have the same, here in the country, visibility or broadcast at the same national level as men's basketball. And then L2 also does things like a lot of college production, even high school production. They do football, soccer. So these are all use cases where at-home production is just a very natural fit. These are productions that, from a revenue standpoint, there's a very excited audience out there eager to watch, but it's not the same huge audience there is for a tier 1 sport. And therefore, from a revenue standpoint, you want to do that production for a lot less dollars so that you can stand to make a good margin on the production, and at-home production becomes a very strong fit for that. And L2 has just, had a number of years of just gigantic expansion by being able to do production at such a low cost level using their LiveU, and they're able to get those productions done for these sports that don't have the same huge dollars associated with them. And I apologize, here, obviously, stick with my American terminology. I mean American style football, and I'll use soccer to mean, real football for the rest of the world. There is a video here. Y'all was just asking if I was going to play. I jumped over and took a quick look at it. I couldn't remember exactly how long it is. It's 13 minutes, so I don't think I'll play it here. But again, I'll share these slides with everybody when I'm done, and encourage you to check out the video because it does kind of dive into a lot of the components of their setup and just their overall kind of business model as well, and how they're approaching their production. So it's a good video. They again use Sony cameras. Pretty common setup here. We've seen all 3 ones we dove into here use some level of Sony cameras, although from 3 different lines in the Sony lineup. They go back to pretty affordable switchers. The Blackmagic Atem line of switchers, are on the affordable side. They started out with 500s and have since largely moved to 300s as a solution. So again, they're using HEVC. And they go back to, again, a pretty affordable end of the total graphics scale, a product called Score HD from Production Consulting Group. It's a graphics package aimed directly at only sports graphics and plugs in with those Blackmagic switchers and renders the graphics there. So some of their unique solutions, they do, again, somewhat similar to NESN, they do send a head photographer out to the site. They'll actually hire freelancer camera operators for their productions. They don't have like a large team of camera operators on their own staff. And so sometimes that freelancer going out to the site is adjusting the camera there. Sometimes they're even using some disparate cameras in terms of the total production, all the cameras in use on it. And so when it comes to a camera shading setup, they'll do some adjustment there on site, of course, make sure that the camera's generating what to that camera technician is a visually appealing image, but they won't be able to get it exactly matching to all the different cameras there on site. One of the things that they'll do is they'll bring that video signal back to the central location and do some further color adjustment there using color correction gear from Aja. AJA, Chris would correct me, it's pronounced AJA. We always say Aja. And they have some, external boxes, again, sort of like a frame sync that you can then do further color adjustment on. And that's how they really kind of end up with all the different camera inputs matching from a color camera shading standpoint exactly the way they want. They'll also send one of the commentators on site so that they're actually there visually watching the game rather than watching the cuts in the control room on the big screen, so that they won't miss any of the action in terms of if the technical director is cutting around or just happens to not cut in time to see a particular key point. The commentator's right there actually watching the game and able to send their comment track back and use that as part of the production. They use an IP-based intercom system for their party line. I think probably a lot of us have heard of Unity, which is again another solution for Intercom party line. And I'll show when I talk about kind of where the LiveU features fit, and one of the features that's forthcoming, we've got a feature that'll make IP-based third-party intercom systems work even better with our system. And then they also handle distribution for a lot of the clients that are hiring them as the production house. At that central location, they'll plug into a fixed encoder and send that back over LTN, which if you're not familiar with, is a smaller national fiber network. They do kind of a mix of totally managed fiber plus virtual private connections on the public internet to create a kind of worldwide network of managed connections to distribute content on. And there are, increasingly using LiveU Matrix as well, which is of course a great option when it comes to the distribution there. So based on those three use cases, taking a look at some of the common problems here, obviously, like I said, we spent a lot of time in each one of those talking about the camera shading, how to plug into a CCU, how it was done traditionally, and how it can be done in at-home production. So, in the traditional model where you had the production van right there on site, and that was probably interconnected to the cameras over some sort of very high-speed connection, triax, fiber, what's called SEMTI fiber. That's not IP-based fiber. It's just a direct fiber link between the CCU and the camera. Then you would just sit there in the production truck on site, make very small adjustments to things like the camera iris or the white balance, and immediately see the results on a bank of monitors right there to sort of match up. Okay, now all of these cameras look the same. So we saw, based on these three use cases, a couple different solutions to that problem when you're doing that remotely. In the case of NESN, they still do it locally. That's their solution. But by doing that locally, again, it's still a much smaller staff and a lot less gear they have to send on site just to get that one task done. And so they're comfortable with that small added expense as opposed to the big savings of not having to send everybody in the full production crew. In the case of the PGA, they did find a third-party solution that helps them solve that. And in the case of L2, in addition to using one person on site that's helping with, the technical operation of each camera, they're doing some of the paint and color correction back at home base, so that even then they might even be using disparate, different camera models across the whole setup and able to get what they consider a great looking final product because they can match up the camera paint settings using external gear. On the LiveU side, this is a part of the whole production stack that we want to vastly improve how we're helping, customers do it. So you might have heard, some talk about a feature coming in 8.5 that now officially is called IP pipe. We sometimes call it layer 2 bridge as well, which is a more kind of technical description of what the feature is doing. This is going to allow just a pure layer 2 tunnel connection from the MMH at the central location back to each one of the units in the field, so that a piece of IP gear you plug into that subnet, that network back at the MMH, would appear at the layer 2 level, the MAC address level, all the way down to the Ethernet port on the units out in the field. And then if you have something that works over IP to do that kind of control, you'll be able to use that control over the link back and forth. So what works over IP? When we talk about a traditional camera CCU, the interlink between the CCU and the camera itself is probably not pure IP. It's probably something higher bandwidth like triax or SEMTI fiber. However, I shouldn't say all of, but a large list of the production level cameras and even the more portable level or what we might think of as like an E&G style camera have now, of course, an option in the modern world to also control the CCU functions over IP. Sometimes that IP actually interacts with the CCU, the physical CCU itself, and then that sends it over the high bandwidth connection. Sometimes it interacts directly with the camera, and the camera itself can be remote controlled over the IP. And again, a lot of the camera manufacturers then have a piece of software that's meant as, here's your software-based CCU. So you could buy a physical CCU for it, plug that in, or hey, you're using this over IP, here's the software-based CCU, and you can control all the same things. And an example of that is Sony, right? Who has a very nice piece of software that offers all of the CCU functionality you would normally get through this physical CCU as a piece of software, and you'll be able to use that over this new IP pipe feature. Sony even goes so far as to sort of advertise that software-based CCU software as a step up from the hardware CCU, because you can do things like have single control over all the cameras. So where with a more traditional CCU setup, each camera has one CCU, and you're turning knobs or controls for each individual camera and comparing the video output on things like a waveform monitor or vector scope. In the software setup, you can sort of go, here's the exact settings I want to use now, click one button and it applies to all cameras. So Sony kind of even goes out of their way to say, hey, this is a new level of control you didn't get with the hardware CCU. And then another example of IP-based control would be a third party like CyanView. So that is how they work. While they might plug into the camera itself on a serial level, if that's how the camera happens to offer its controls over these functions that we're speaking about here, the connection from that centralized box to their individual little boxes you're plugging in is IP-based. So that'll be able to go right over the IP pipe functionality that's going to come in 8.5 and give them a kind of new channel to do that. They were using things like a single cellular connection before as a way to get IP remotely. And, I think we all know the kind of trip up there. That's going to work for you if your single MiFi is working great on site. But if you happen to bring all Verizon MiFis to the site, one for each camera, and then at the golf course find that you're in a little valley that happens to be a slight dead zone for Verizon, then you're going to be in a problem. So using something like our IP pipe feature, where you're relying on the connectivity and the unit, which can pick from many different connections, you're going to have a more reliable connection. And that is where my conversations with CyanView so far, they're pretty excited about that feature and the link up that's going to enable. Frame synchronization is another problem. We spoke about it mostly with NESN. I should mention for the other ones, PGA and L2, they largely just found that the frame synchronization we're offering today, what we've brand named kind of LiveU precision timing was close enough for them, and that was good for their productions. That timing is hopefully mostly, especially when you're using AVIX, could be plus minus one frame. I think it's safer, and speaking frankly here, not that you'll necessarily see this in all of our marketing literature, it could really be up to 2 frames. And I think in some of the recent tests that some of you, I've worked with individually on some of you and have done with some of the customers, they were finding that at different times it could kind of go all the way up to 2 frames. So that level of timing today is based on each individual unit sending back a different stream, and just the very precise way that we're able to measure the actual delay and the precision of our glass to glass delay that you're dialing into each unit, keeping those within that plus minus 2 frames as the video signal comes back. So how that was solved, prior to any new feature, and then we'll start talking about new features around it. With NESN, as I discussed, they're using external frame syncs, and that lets them not only ensure that there's great genlock, although of course all of our servers have genlock input as well, and that helps tighten up what might be 2 frames down to just plus minus 1 frame. They also then have the further ability that if, as they're doing the pregame test, they visually see, boy, this could be slightly tighter, camera 3's obviously a little bit slower, then they can go in and make a fine-tuned kind of frame adjustment on each one. And again, I'll find out the exact model of frame syncs that they're using for that. The other thing we wanted to note here, just our experience here in the US, was that certainly different sports have different feelings on this, right? It's a little bit unique that NESN, or I should say it as, it makes sense that NESN went in and used this kind of external way to further tighten up the frames, because for a sport like baseball, where it's a large field and you're using kind of close-up shots and cutting between them very frequently, then that could highlight that problem of frame synchronization. Some other productions, again, if it's using more wider shots and you're a little less frequently cutting between all the action, it has less of an impact. And we see, as we're explaining kind of the pros and cons of at-home production to some sports production producers that maybe don't understand all the nuances here, are able to kind of talk about whether this is going to work for them or not. I think the really good news here, and probably everybody's aware of it, but with the launch of the LU800 quad input this year, that's going to be when you're using it all wired back to the same unit, which is a slightly different model than using individual units, but still a very viable model, and it will fit a lot of productions out there. Those individual streams are going to be in perfect frame sync because obviously they're being coded on the same unit. We're able to then look at each individual frame and stamp them as these are all the same frames. And then even though they come back as 4 separate streams from that unit, coming back to the same MMH, where they're able to output it as the same frame on the MMH. So that's a feature we'll see just a little later this year in 2020. At-home production obviously has a very heavy communication need. Not that all of our use cases where people are using LiveU didn't always have kind of a communication need, but for sure, one-way IFB is probably not enough. I mean, when you look at how these productions were traditionally done, they were already using Intercom, not IFB, as their communication method, and they need to, now that you're doing it remotely, it's just even more important to have it there. So prior to us having the full Intercom feature, we saw some kind of solutions grow up out there, like the PGA example, where they used their own little wired box, used a combination of the channel we were at that time offering, IFB, plus the additional audio channel coming back as the way to do kind of two-way communication. So they kind of found their own solution. And then you had people out there that were using third-party IP-based solutions like ClearCom as the way to do that communication. What's going to change, what just changed for us is, of course, we've launched in 8.0 our own Intercom feature, and I think we've got some customers out there trialing that right now. I would call it in shakedown cruise mode. It's new in 8.0. It's a very new feature for us, so I'm sure we'll be seeing some discoveries around it of things could be improved, and some improvements coming in the further point releases of 8 and 8.5 down the road. And I know we have some planned roadmap improvements to it as we get to 8.5 and 9.0 as well. But it's great that it's launched, and we're really excited to have customers trying it. And so we think that's going to be able to just step right in when they say, well, we need two-way communication. Now the answer is we have it. Let's use that, right? Let's use our Intercom feature. Plus, if they're already heavily invested in an IP-based Intercom feature like ClearCom, then once we launch this IP pipe feature, that's IP-based Intercom was one of the use cases we exactly had in mind with IP pipe. So they'll be able to then keep using the IP-based feature, use it just the way they do. If they use it to a app on the cell phone today as their way to do it, that's fine, just keep doing that. But if they want a IP pipe to the location that's coming over the gear they're already using, the LiveU gear, then this layer 2 bridge is going to operate for them as a way to interconnect that. It has a lot in common with Intercom, at least from the standpoint of where we stand on solutions for it, is Tally Light. So when we first started with NESN and we didn't have any feature around this, it was, well, we don't have a solution for you on that. And they still went ahead with using the at-home production model. But what we now have is, yes, we have a Tally Light feature. Just in case anybody's not familiar, Tally Light's the ability to say, to show which camera is live, so both the camera operator knows, that they're currently the live camera based on the switching that's happening back in the switch service in the central location, and then also if that happens to be a camera that's not just a shot of the field or a shot of the game action, but maybe involves a commentator or a personality that's part of the production, they also know that camera's live, and it's time for them to kind of look in the camera and do their job. Now we've got a feature for that. We've got our own very nice device that'll light up when plug it back into your switcher back at home base through connections called GPIO. and that'll light up when that's the camera that's switched to. And then in addition, just kind of, we're testing it right now with NESN as of the latest 8.x release. There's a further GPIO connection on the side of that light, serial connection on the side of that light, and you can plug that into the camera CCU. So it also facilitates the idea that rather than relying on our literal light to light up and say this is the camera that's live, what it would actually be doing is as you make the switch, the signal is transmitted over the LiveU protocol to the unit, and then the unit is over that serial connection on the little light device itself, telling the CCU on site, you're the camera that's live, and then that camera will know it. And again, that would enable some things like, for instance, if the camera already supports showing tally light information right inside the viewfinder rather than just as a actual lamp on top of the camera, then they'll be able to see that right in the viewfinder. And so that feature is available now. We've had people using, of course, just the pure tally light device already, but we've got NESN just now testing out that further link of the serial connection between the light and their CCU. It's also solved by some third parties like CyanView, and that's the way the PGA was using it. And if that's the way, you know, somebody solves it for African production, that's great too. So just in summary, and then we can get to a bunch of questions. Obviously, you know, when we first kind of started out with the LU500 with our first customer, NESN, we were really at that point doing mostly just video backhaul for them. And they were solving, you know, all these other problems a lot of different ways. In just a short time, a couple of years since we really became aware of the excitement around the at-home production model and how this is a rapidly growing trend in sports production to now, you've seen LiveU launch a bunch of features specifically aimed at, let's take all of that work, really key components of doing a remote production and make it much easier to do with our gear. You know, Intercom, tally light, our video return feature, and now with the IP pipe feature coming in 8.5, camera control, CCU control, and then with the launch of the 800, even tighter frame synchronization. So I think we've done a pretty good job of hitting this kind of full production stack. Oh, you've got all these needs when it comes to production, the Intercom, tally light, camera shading. Yes, these are all things that we can now help you with. So again, just a kind of little summary of the way the different different customers we dove into here solved some of these common problems, common needs, and when it comes to production, and then what's just around the corner this year in 2020 in terms of features coming from LiveU. So I think that's it. And I'll leave it here on this slide for any questions that we have.
Daniel, thank you very much. Very interesting. So guys, if anybody wants to ask Daniel or to give feedback about, I know that a lot of you have been using remote production in other places. So, feel free to share and provide your feedback and ask questions. Guys, don't be shy.
I think Luis de la Rosa, who's one of the pre-sales engineers here in the U.S., was able to join as well. So, Luis, I don't know, anything you feel I missed or you want to add on to everything I said as well, feel free.
Will do, thanks. And everything was on point.
Because Luis has actually been involved with NESN since the earliest production, so he's got a lot of good insight.
Hi, this is Selvam from India. I hope it's all great. It's very for the we are maybe using this from this year using the LiveU from 4K from India. So most of the sports we are like to go for with the LiveU. Now most of the time I'm using an Webinar for the start. Sounding good, great.
Good.
Hey, Dan, one thing to add also, NESN's using the video return in the booth for their talent and commentators. So they're also using that solution.
Nice.
So mostly it will be suitable for the 800, the new model, right?
So all of the examples I gave today, when I give you the slides after, you can go back and look, they're all using other units, not the 800 today. Some of them even started with H.264 based units. All of them have upgraded to HEVC, but are now using either the 600 or the 300. I think the 800 for a lot of those customers that are already doing it today is just going to be another upgrade, chance to use, for example, perfect frame sync if they want to use the quad input 800. But they've been able to accomplish at-home production today using the current units that we have. 800 for sure is going to be a nice big upgrade, but I think they're all three examples of how it's very doable with current units.
IP pipe, LU600 and LU300?
Yes. So NESN, for instance, uses 600s, L2 uses 300s. If I remember correctly, the PGA uses 600s.
And IP pipe will be supported on both?
Oh, yes. IP pipe supported on both and the 800.
Scarhoy make an RCP IP controller, which we understand will be able to IP into some of the lower tier handycam sort of ENG style cameras as well. And so the application of IP pipe and say, for example, LU300s on a lower tier remote production, that Scarhoy controller may well be able to do a lot of that CCU control, direct IP like Ethernet straight into the camera. That's some of the plans that we're looking at the moment.
That's great. Yeah, it's a good point and worth noting. I kind of didn't dive into when it comes to CCUs that in the kind of camera lineups, there's a split there between it tends to be the middle production up to the very high production cameras that have full CCUs, their own full third-party CCUs, and the more portable cameras, which can be appealing for both, lower cost productions and for the more portability of the camera, tend to have remote control of those functionalities, but they might not have their own dedicated hardware CCU. And so then part of the things that these third parties are offering, like the one that Chris just mentioned, and also the third party I had mentioned, SignView, is they're almost sort of providing, here's a CCU-like control for that camera that's got all this functionality if you dig deep into their API, but the camera manufacturer themselves aren't making something available for it.
Are you able to drill into the intercom feature a little bit more? The two-way?
Sure. So for us, the new intercom feature, it's changes on the underlying protocol that the unit's using, changes a lot about the back end so that it's two-way communication. But the nice part about the way the R&D team built it is it doesn't really change the kind of day-to-day, very detailed parts of the setup. In other words, you literally still plug into the audio 3.5 millimeter TRRS jack on the unit. You just now plug into it with a headset that has a mic as well. And back on the MMH side, you plug into it with the same list of supported audio devices that we have there. You're just now using the output connectors on those as well as the input connectors that you're already using for IFB, and you get two-way over it. So in the kind of demo kit we've been working with here to sort of show that off, we identified a TRRS-based connector headset to use with it, and I could send you that exact make and model for everybody to plug into the unit side, and we just took one of already on our supported list right off the shelf of the hardware we were offering, a rack-mounted box that's got, I think, 4 connections, so it really has 8 XLR connectors on it, input and output for each of the 4 connections, and then you plug that in and wire that into, you can wire that into anything. I mean, I think in a lot of cases they're wiring it into an existing intercom system back at home base that's got a bunch of inputs and outputs on it. And then the communication between the unit, between the server down to the unit is now two-way. When somebody talks back, it comes out as the audio output on that channel. To do something like Party Line then, which is on our roadmap to make easier, but to do something like Party Line, you've got to be taking the inputs and outputs on that box back at home base and plugging that into a further intercom system that understands, hey, I want to take these 4 inputs plus the control room, plus maybe one other, input output here back at the studio, and put them all on the same mix minus connection so that when one person talks, everybody hears it. That's where you can control over who's actually in the party line would be an external from us. But what we're facilitating there is that the communication's two-way.
Push to talk on the TRRS headsets. We typically use and have used a lot of Unity in any of the remote production stuff and the flyaway kit stuff that we do here. Push to talk is a constant problem. Do we support that in the comms or will we? What's the position?
So I don't think we have anything built in, and this might kind of go right at the edge of my own technical understanding. Is something I might have to dig into, but I don't think we have any support in our own current setup that facilitates specifically push to talk. I think you could couple the TRRS connection with a headset that has a always muted sort of setup, and you push to kind of activate the mic and get that to work. My own experience with Unity, I'm sure they have some analog in and out options as well, but my own experience with Unity is that they do have sort of a full IP system that you can use with it, and so they might be a good fit to say stick especially if you've got a user that's already using Unity, stick with Unity, and rather than plug that into specifically our intercom system, plug it into the IP pipe feature so that you're just facilitating the IP communication Unity is already doing, and then hitting some Unity devices down at the production side over IP.
Yeah, so that would work to a base station. Unity as a client typically uses a phone. So, but what the fundamental problem that Unity brings that the two-way comms with LiveU solves is the battery issue. When you're using your phone as your Unity client, you burn the battery way faster. So then you're talking about carrying an extra battery pack. So if we shift the comms over to two-way comms, particularly onto, and is it LU300 and LU600 or just LU600 for two-way comms?
300 and 600.
Spectacular answer. Knew you'd go there, Dan. So when we shift comms to there, then we actually eliminate a failure point, which is the batteries running out for remote production. So that's huge. There are another question. We can replicate IFB audio channel 1 to be then played across all 4 channels. So we can put a single source of audio in to a audio to USB device, and just by changing the some of the scripting on the server, replicate that. A, can we do that still in a two-way environment? And B, on the return path, is it going to be on a 4-channel server, 4 separate audios out, or do you think we'll be able to sum them at a single output?
So I think.
Or am I asking too many technical questions?
No, that's good. It's good feedback, and I just our two-way intercom system and intercom systems in general are an area I need to myself keep learning on. So I wouldn't call it my area of deepest expertise, but I know that the configuration you're talking about, where you're sort of going into the audio level configuration, the operating system on the MMH to say, actually map these channels this way. I want all, this one input to go to all 4, should work the other way as well. All the incoming audio channels, I want you to just, send out mix together, send out of this one output. But I'm sure we haven't tried it that way in the lab yet. So that was probably something we should, sit down and try, and I could put it on my list to do, to sit down and try and see how that works.
We'll have a crack at breaking it, mate. That's fine. So I think two-way comms, the reason I ask about the push to talk is it's the kind of that last piece of the puzzle. I think you're right. I think the ideal in the interim is a mic that's always on, but physically muted on a device. That's a solution. It's not necessarily the ideal answer, but it's a solution to the problem. But being able to bring two-way comms directly into the device, which is, they're transmitting with, that has enormous value, especially if at the same time we've got IP pipe and like a CCU over IP. It dynamically changes dynamically changes remote production, like massively. It's a game changer.
Yeah, I know the sports sales team here as well is pushing for the upgrade. And now that we've got two-way, let's keep going and add the rest of the features that are missing there. And there is a roadmap for that, and I can share more about that roadmap once I lock it down myself. But we definitely do have plans to, this was just the start of it, key first feature, and then plans to keep going on the rest of the functionality that we need there.
And just to clarify, two-way comms is in 8.0.1?
It is.
Or is it a beta? Is it? Okay. I'm going to break it for you and tell you what happens.
I'm sure you will.
I'm sure I could think of some more, but I'm happy to let other people have a go too.
Yeah, guys, any other questions? Any other things that you need from Daniel to help you do more these kind of productions in Asia? What are you still missing? What do we need?
More customers, I think, is the short answer.
Customers, there are plenty. We just need to bring them the solutions, right?
Well, this will help. This will really help.
Yes, I think all of the case studies that Daniel is talking about, we're already doing today with the existing units, the 600 and 300. The 800 will be a big improvement, especially on the multi-camera and perfect sync between multiple cameras connected to one unit. But still, we can still continue to do the remote production with the existing products that we have today, even before the 800.
Yeah.
Yes.
Yeah. It depends on the customer. For example, we already did for that using LiveU 200 a couple of years ago for the internet movie. So it can be doing that for the remote production. But basically for the sports guys, I trust that the time synchronization is the master. Okay. So we are waiting for the 800. Maybe that will be the good chart to test for that market.
Okay.
Yeah. With the 4 camera together, it will be the opportunity to test to see what's the feedback, right?
We've done golf on LiVU 200s. I think that was Gordon speaking earlier. And our customer was quite happy with that. We know that it will only be better with the tighter timing capability of the HEVC product line. But the customer has done several golf remote production events with LiVU 200s and been comfortable with the outcome. Basically, all they've done is if one of the cameras does drift, and can happen on the H.264 line, a stop and a restart, which is 20 to 30 seconds and fairly easy to make happen, has brought that unit then back into realistically plus or minus 1 or 2 frames.
Mm-hmm.
Yeah, that's a nice tip there on the restart. Definitely the H.264. I mean, just knowing how the underlying encoder worked, the H.264 encoder didn't have access to the same high precision clock that the HEVC one does. So you could definitely see even more of an issue there when you're using the H.264 units. The HEVC units, hopefully are tighter overall, but we definitely have found that some productions, right, in some cases rightfully so, and speaking frankly, in some cases just because it's very much the way they're used to doing it, sort of demand perfect sync. And I think that is where, the 800 will be a solution for that set of customers that just have no wiggle room there. The examples that we've shown here, PGA and ESN, they were very open to, okay, if you're that close, 1 to 2 frames, let's test it. Let's see how an actual production goes and see if we're comfortable with it. And at the end of it, they were, with the, added example that NESN wanted that last, one last mile of control to say, well, we can still kind of go in and fine tune that a little bit if we need to.
Another question about sync across servers. So I talked about 5 cameras, and so clearly that is 2 servers. What's the, like, we got away with it basically holding our breath and leaning left, but is there a better way to sync 2 servers in either platform, or is it still hope for the best?
So today, because again, that precision timing is just based on the accuracy of the glass to glass. If the 2 servers are plugged into the same Genlock source, then I wouldn't necessarily expect it to be any better or worse coming out from a different server in terms of that plus minus up to 2 frames across the servers. For the forthcoming 800 feature, they will have to come out of the same server to stay in alignment, because you need that decode space to be in the same memory space to look at the different timestamps on the incoming packets and frames and say, these are clearly the same frames, let me output them. So you are going to have a max of 4 there, which matches, of course, on the 800 side, the 4 inputs on the 800. I didn't want to talk in this presentation about the roadmap past that, but because it's a little further forward, I don't know that it's going to be in 2020, but suffice to say, this question of exactly accurate frame sync, even across disparate units or even across servers, as you're asking for there, is forefront of my mind and the product team's mind, and something that we're working on in terms of a, kind of complete end-to-end feature that would mean even disparate units and even disparate servers are all in perfect frame alignment, which is technically possible. There's just even more building that has to take place to get there. And so that I didn't want to include it here because we're getting a little further, way down the product roadmap.
The 800 also, they fill different roles, is my observation, because the 800 is going to be awesome, and having, 3 or 4 cameras going in sync, coming out in sync, that's glorious when cabling back to a central location is ideal, and when transporting those 4 cameras over a high bandwidth cellular plus landline or whatever link is a workable solution. A lot of the value of at-home production is the cost saving in the broader, like the golfs and the triathlons and things like that, where a quad 800 isn't going to be necessarily all that helpful because it's kind of hard to cable to a camera on a motorbike. It's funny, but hard. So
yeah, I agree.
It's actually going to fill out the product line very nicely. It's going to give us that nice array, and I can see clients that might have 4 cameras that are tied together, but 2 cameras that are remote, and so they'll run an 800 and 2 300s or an 800 and 2 600s, and that I can see that as the way this develops, because that's just, I think, the way what at-home production will enable.
Yeah, definitely. Looking just at the, list of customers, the 3 use cases that we looked at here, I would assume, maybe it'll turn out to be true, maybe it won't, but I'll assume that NESN will test a quad input 800, as soon as it's available, because that would be something they would be interested in for some of their production. Even though ultimately they'll use more than 4 cameras, I think they'll be interested to test it. But I bet the PGA will stick with the solution that they're using right now, because they need those cameras to be very remote from each other across the larger golf course. And I bet that L2 will stick with the setup that they're using now, just on the economics of it, that the 300 fits very well with their budget and with what they're doing, and is sufficient for them right now in terms of all the capabilities that it has. So they'll probably stick with that, and the 800 won't be a great fit for them there. So I think if there's no other questions, we can wrap this up. I'm going to send everybody the slides. You can get those links to the deeper PGA case study in case you want more details there. And you can get the link to the L2 video on Vimeo, which is, again, very good very good video to watch. And as a little bit more technical information rolls in, because I had questions out to the PGN, the exact Sony camera model they were using, and to NESN on the exact frame sync model they were using, I'll just work with Yoel and Asaf to send that out to everybody. I certainly appreciate everybody's time today.
Thank you very much, Daniel. Thanks everybody for joining. Please, if you have any more questions, please send us an email. And also, if you have any specific requests for additional sessions like that, we'll be happy to arrange more on subjects that can help you to better promote the solution. So let us know what you're interested in, and we'll prepare additional sessions like that.
Thank you. Yep.
That's great. Thank you.
Thanks, everybody. Good night.
Thanks, everybody.
Good morning. Bye-bye.
Bye-bye.
Thank you.